Hey guys, here's our first set of notes for Unit 8. Today we're going to be talking about stoichiometry. So often in this class we kind of relate chemistry to cooking, so we'll do the same thing with this unit to kind of help you better grasp what this unit is about. So we are going to perform stoichiometric calculations. We can determine mass relationships between the reactants and the products. And then probably next class, I will teach you how to calculate limiting reactants and percent yield. So these are the things that we're covering in this unit. First, we need to talk about mole-to-mole ratios. You should already know what this is. A mole ratio is the ratio between the amount in moles of any two compounds involved in a reaction. So for example, what's the mole-to-mole ratio of nitrogen gas to hydrogen gas? So here is that chemical formula. Oops. Let me go back. No. Okay, so here's my chemical formula. If I'm looking at the mole-to-mole ratio between nitrogen and hydrogen, I'm just looking at the coefficients in front of those compounds. So in front of the N, there's nothing, so it would just be 1. In front of the H, there's a 3, so it would be 3. So the ratio is 1 to 3. What's the mole ratio of sodium hydroxide to water? Let me just pull up my notes so this will make a little bit more sense to you. Okay. If I'm looking at the mole ratio of sodium hydroxide, that would be NaOH. There's a 2 in front of that. And then it says to water, that's H2O. There's also a 2 in front of that. So if it's 2 to 2, you can just call it 1 to 1 or just 1. Okay, we'll come back to those notes in just a second. So in stoichiometry, it is basically just proportions. So like if you're cooking and you have a recipe for 1 and then you need to double it, you're just making a bunch of proportions. Sometimes you can do that in your head. Sometimes you need to actually write it down. A proportion is a part, share, or a number considered in comparative relation to a whole. This is also called a ratio. So here's a scenario. A recipe for Thanksgiving cranberry sauce calls for 1 pound of cranberries, 2 cups of water, 2 cups of sugar, and that produces 6 servings. What ingredients and how much do I need to buy if there will be 18 people at my family's Thanksgiving? So I would need to be able to figure out each ingredient, how much of each ingredient I need to buy so that I have enough for 18 people. To do this, we can set up proportions. So today, I want you to write that as a chemical reaction. Let me see if I can get my notes here. So I have 1 pound of cranberries, 2 cups of water, and we have 2 cups of sugar. That gives me 6 servings of cranberry sauce. Okay, so the first thing you need to do in stoichiometry problems is write your given on top of the equation. So I'll do mine in green. So I'm looking for pounds of cranberries, which that original equation said I need 1 pound, but we need to figure out how many pounds we need for 18 people. So we can put our 18 over our 6, because that's the same thing. And we're going to put our ratios or the numbers that we know on the bottom. So here's the thing. If I have 1 pound of cranberries here, I'm just going to bring that number down. So I'd have 1 pound of cranberries here. I have 6 servings here. That gives me a ratio. I have x over 1 equals 18 over 6. Now all I would need to do is cross multiply and divide. So cross multiply here, that just gives me 18, and then divide by this one, and that gives you your answer. So it kind of looks weird since these are not chemicals, this is food, but it'll make more sense in a little bit, hopefully. Basically, you're using the equation and you're writing above and below to try to solve and set up a proportion. Okay, so I could do the same thing with the water. Same thing with the sugar, and that's what is on here. I basically need to cross multiply and divide 2 more times to figure those out. Okay, chemical reactions are just like recipes. For balanced chemical equations, ingredients may look a little bit different. Our units are going to be in moles for the most part. So here's an example of what that looks like. The recipe in the equation says I have 2 moles of hydrogen, so H2, and 1 mole of oxygen, and that makes 2 moles of water. So remember that those coefficients are telling me how many moles of each substance that I have. Here is an example. How many moles of hydrogen are required to make 8 moles of water? So let me do this with you. Okay. Okay, let me change colors here so it's easier to see. Okay, so I'm just gonna copy down my equation real fast so that I can write on it. So it says how many moles of H2? So right above H2, I'm gonna put my question mark. That's what I'm looking for, moles of H2. I need 8 moles of water, so I can write 8 moles above water. So this is where whatever your equation has, you're just gonna bring those numbers down. So I'm looking at moles, right? I know that I'll have to have moles down here since that's what I have on the top. Those need a match. If I'm talking about moles, all I'm gonna do is bring that coefficient down. So I have a 2 for that mole. Again, this is moles. I'm looking at my coefficient, so I have a 2. Okay. So if I want to solve this, I'm going to cross multiply. So 8 times 2, which equals 16. Then I'm going to divide this way, so divided by 2. That means x equals 8. So we just solved that problem. All right, let's do another one. How many moles of H2O could be produced from 0.6 moles of oxygen? So let's write down the equation again. Let me change colors. Okay, so I'm looking for moles of water. So above water, I'm going to put my X. That's what I'm looking for. I have 0.6 moles of oxygen. So above this, I'm going to put 0.6 moles. Okay, this is where I need to bring down my units. So if I have moles on the top, I have moles on the bottom. Moles on the top, moles on the bottom. Since I'm talking about moles, we're going to use the coefficient. So just bring your number down. There's not a number in front of O2, so I'm just going to put a 1. There's an invisible 1. And then I need to cross multiply and divide. So 0.6 times 2. Which equals 1.2. And then I'm going to divide that by 1, so it equals itself. So my answer is 1.2 moles. We can also do mole to mass calculations. So it's the same basic concept, but when we start talking about mass, we're going to need things like our molar mass, which means we're going to need a periodic table here in a minute. So here's my equation. It says how many grams of hydrogen, so I'm looking for grams of hydrogen, are produced from 6.2 moles of ammonia. So here's ammonia, 6.2 moles. I'm going to bring my units down. So I have moles on the top, got moles on the bottom. I know that I'm going to use my coefficient since we're talking about moles. On the right side, I have grams on the top, so I've got to have grams on the bottom. Anytime you have grams, you are using the molar mass. So I need the molar mass of 6 hydrogen, which is 6.048. So cross multiply and divide. We're going to multiply this number times 6.2, which is 37.49. I'm going to divide that by 2. And I got 18.74. My unit is grams because that's what the question was asking for. Okay, so this is kind of repeating what I just did, but the main thing is remember that your units on the top and the bottom of the equation need to match. So that's why I had moles right here, I had to have moles on the bottom. I had grams right here, I had to have grams on the bottom. Anytime you have your unit as moles, you've got to use that coefficient. Anytime your unit is grams, you need to go to the periodic table and find the mass. Okay, so here's kind of walking you through what I just did. Let's do another one. I'm gonna go ahead and write my equation out. I'm running out of room here. CaOH2, okay. All right, how many grams of CaOH, so X grams, question mark, would be formed with 3.2 moles of calcium carbonate. So make sure your units on the top and bottom match. So if I have moles on the left, I'm going to bring down moles. There's not a coefficient, so it's a 1. On the right, I have grams on the top, so I need grams on the bottom, which means I need to figure out the mass of CaOH2. So remember that that little 2 on the outside of the parentheses means I have 2 oxygen and I have 2 hydrogen. Oops, let me go back. Okay, so I need to find my mass. So you need to find the mass of calcium. We have 2 oxygen, we have 2 hydrogen, and you need to add your mass together. So I'm gonna go ahead and do that real fast with you. 2 times 1.008. And then let me grab a periodic table. So the mass of calcium is 40.08. I need to add all those together so I can get my total mass. You should be doing this with me. My total mass was 66.118. I'm going to plug that in up here. So now I have everything I need to go ahead and cross multiply and divide. I'm going to multiply this number times 3.2, which is giving me 211.58. And I'm going to divide that by 1 so it stays the same. So that is my answer. Okay, so here's more mole to mass calculations. How many moles of nitrogen are produced from 6.35 grams of ammonia? So you guys should try to do this one on your own. If you need to pause the video, that would be great. And then you can check your answers with mine. All right, first step, write what you know from the question above the equation. How many moles of nitrogen? So above my nitrogen, I'm writing X mole question mark. And I have 6.35 grams of ammonia, so I can write that on there. Bring your units down. I have grams, I have moles. That means I need to add up 2 nitrogen, 6 hydrogen, and find the mass. So add those together. Mass is 34.068. That's what you need to plug in up here. You're ready to cross multiply and divide. So 6.35 times 1, so that stays the same. And then we're going to divide it by 34.068. That's going to give me 0.186. My unit is moles because that's what the question's asking about. Okay, same thing. Try this on your own, pause the video, and check your answer with mine. Okay, so I only wrote down the part of the equation that it's asking about just because I didn't have room. But it says how many moles of water are produced when 25 grams of this. So bring your units down. Grams, moles. Anytime you have moles, you're using the coefficient. For grams, I need to find the mass. So I have 4 carbon and I have 4 hydrogen. So go ahead and add up your mass if you haven't done that already. So my mass that I got was 52.076. If you get different numbers than I do, please let me know if I messed up. So now I'm ready to cross multiply and divide. I have 25 times 2, which is 50, divided by 52.076. 52.076. And I got 0.96. I was looking for moles. That's my unit. Okay, so we've done mole to mole calculations. We've done mass to mole. You can also do mass to mass, which means you won't use moles at all. So you're still going to do the same thing. It just means that you're going to be finding the molar mass twice. So again, I'm just going to write down the part of the equation that I'm using because I don't have enough space. You don't have to do that. You can just write yours on your paper. So I have 2Na plus 2H2O. Okay, pause it, try to work it out yourself. Okay, so I'm looking for grams of water. That's where my X goes. I know that I have 0.025 grams of sodium. I need to bring my unit down, which means I need the mass of both of these. So 2 sodium, let's see what that is. 2 times 22.99. This is going to be about 45.98. Your numbers might be slightly different than mine. That is okay. And then we have 4 hydrogen, 2 oxygen. Make sure you add those together. So I got 36.03. I'm ready to cross multiply and divide. 36.03 times 0.025. I got 0.9007. And then I'm going to divide. Let me double check my math real fast. Times, yeah, and I'm going to divide by 45.98, and I got my final answer as 0.0196. This is grams. Okay. All right, I think this is the last one. Pause your video, try to do this on your own. So I'm looking for grams of hydrogen, so X gram. I'm gonna change colors actually. And I have 50 grams of nitrogen. So bring my units down, find the mass. Nitrogen is about 14.01 times 2, 28.02. I have 6 hydrogens, so add that up. Cross multiply and divide. 50 times 6.048 equals 302.4 divided by 28.02. And I got 10.79 grams. That's your answer. All right, so next time we'll talk about limiting reactants and I will go into more detail on that stuff. Please let me know if you have questions or if I messed up on any of my math. Please shoot me an email.